Good morning, dear students. Today we will learn about logarithms, which is chapter 1 in unit 1. So, in our subject, we have 6 units. First unit, in the first unit, chapter 1, named logarithms. So, at your school in previous or last year or 9th or 10th, I think you learnt there some formulas or definition, some problems you may did there. So if you don't know about logarithms, here I will explain, I will tell you what is logarithm and what is the topic and what are the formulas, what are the properties and how to do the problems and what is the use. So these we will discuss. First of all, this is a different concept, logarithms, and it is mainly used for solving the equations or solutions, or it is useful to simplification, where to simplify the equation or calculate the function, if we have difficult, then by applying or by using logarithms we will get easily. In simplification, it is very useful to us. So let us see, and all of you have textbooks. The textbook is very essential in our mathematics subject, and yesterday I told you to read the chapter and see the example problems, properties, formulas, and if possible do the exercise problems. I hope some of the students are did the problems by observing examples and by understanding the concept, and those are not attended yesterday's class, so you need not to worry. Yesterday we discussed the exam pattern, question paper pattern, what is polytechnic and what is semester, like this we discussed. So if you not attended yesterday, you may follow the video and you may see the PowerPoint presentation. I will share you once again in our maths WhatsApp group, so that you can see PPT and video and you can know what is the polytechnic, what is exam pattern, what is the question pattern. Like you can get a you can get a picture about the system or exam or diploma or subject. And now we will discuss about logarithms. So let us see what is logarithms. Here definition given, two types of definitions given. Let us first one and we will understand. It is a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. Theoretically here given, so I will explain with suitable examples. It is a quantity representing the power. To represent the power, we will explain in terms by using logarithms. So let us see, after reading the definition 2, then we will try to understand the definition 1 also. So the exponent or power to which a base must be raised to yield a given number expressed mathematically. X is the logarithm of n to the base b if b power x equals to n, in which case one writes x equals to log n to the base b. So by seeing example, we can easily understand. For example, 2 power 3 equals to 8. So here the power 3 can be expressed in other terms. Up to now we don't know, but here we have a method that is called logarithm. The power also expressed in terms of 2 and 8 by using or by expressing the method called logarithm. Therefore, 3 is the logarithm of 8 to base 2, or 3 equal to log 8 to the base 2. Here logarithm we can express as a log. So 3 is expressed in terms of 2 and 8 in the form of log. So log 8 to the base 2. Here base 2 is taken to the log, and right side 8 taken at log. So 3 equals to log 8 to the base 2. So I hope now you will get the point. What is logarithm? To express a power in terms of base and right side values, we are taking the method. That method is called logarithm. So up to now we don't know how the power is expressed in the terms of remaining 2. Here 2 terms 2 and 8. But by using logarithm we are expressing the power 3. So 3 equal to log 8 to the base 2. And in the reverse also we can express. Here base 2 is a log. So write as it is 2, and right side 3 we can write at power for base 2 power 3 equal to 8. So vice versa, we can express into a log, and from log to normal. So here the power can be expressed in terms of base and right side value. So in the logarithms we have some rules, or we can say properties, or we can say formulas also. So here few formulas are given. Let us read or say. The first one is, see the right side, the PPT. log m into n to the base b. We can take any base. Here we are expressing with generalized letters. So if we have product in the log, so what to do? We can see the right side, that is log m to the base b plus log n to the base b. So here the product can be expressed in the addition form. Next, second, log m by n to the base b. Here the division is transformed into two terms, that is log m minus log n. The bases are same as it is, that is b. Next, log m power k to the base b. So in the log we have the powers. So the power k we can write at front side, that is the multiply with log. So k into log m to the base b. Next, fourth one, log 1 value is always 0, whatever the base may be. So log 1 equals to 0. Here log 1 to the base b, b means any number, equal to 0. Number 5, log b to the base b equals to 1. So log and base, when they are both are identical, we can say that value is 1. Number 6, log b power k to the base b. We already know rule number 3 tells us the power can be right in front of log as a product. So k into log b to the base b. The above formula said that log b to the base b value is 1. So k into 1, k. Next, if the log is kept in the powers, that is b power log k to the base b. Here base and the log's base are equal, then that is get cancelled. We can write directly only logarithm, that is k. So log value we are written here, the k only. So these are the rules. Wherever needed to simplify the problems, we will use this. And one condition is given. Let us see what is the condition. B is greater than 0. That means the base is always positive, but b is not equals to 1. The base should not be 1, because 1 power anything we can say it is a 1. So base should not equal to 1. And m, n and k are real numbers, but m and n must be positive. So real numbers means what? The numbers which are whole numbers, natural numbers, quaternary numbers. So all these numbers we can say integers also, we can say real numbers. But they should be positive. The k may be no need to positive. So these are the conditions for the rules or properties or formulas. These rules are used to simplify the given question or problem or function. Now we will move to next slide. Look here, left side we written logarithm and right side exponent. So So exponent form is suppose n equals to a power x. Here a is a base and x is a power. So a power x value is n. To convert this into the logarithms, we will do the here right side a is the base and kept it to the log as a base, and n value we are taking it log. So log n to the base a equals to the power is x. So here we are expressing the power in the logarithms terms. So power is equals to log n to the base a, and vice versa we can convert it into a exponent form. So as per our required, we will shift to logarithms or we will shift to general exponent depending on the question or function or simplification or answer. We will convert from exponent to logarithm, logarithm to exponent. The process is, we have to remind, the base will same. If we observe at logarithms and exponent, the bases are same. See here, a is a base to both common in logarithm and exponent. So this is, we have to remember, the base is same and it does not change. The power will change. So the power is expressed in logarithms, and in the exponent the value is expressed in terms of power. So if you know this logic, we will easily convert which way we want. Look here, the index equal to logarithm. Here a is a base in both the terms, and the power here taken as a right side and the value is taken as here left side. So if this much we know, or this much conversion we understand, then we will easily shift to logarithm to exponent, exponent to logarithm. And some more examples given here, let us see. Here m equals to log x to the base b. Then x equals to, we will express as a b power m. And similarly, n equals to log y to the base b. If we want to in the exponent form, we can write y equals to b power n. Next, logarithm formulas. Log 1 to the base a. A means any number. The value is 0. So log 1 value is always 0. And log a to the base a equals to 1. Base and log, if both are same, then the value is 1. And log 0 to the base a, we have two values, that is minus infinity if a is greater than 1. That means if base is positive, we can write minus infinity. If base is less than 1, then we can write infinity. So log 0 contains two values based on its base. If it is greater than 1, we take minus infinity. If it is less than 1, we took plus infinity. Log x by y to the base a equals to log x to the base a minus log y to the base a. So division is expressed in terms of 2 by keeping subtraction. Next, log xy to the base a. So log x to the base a plus log y to the base a. So product we can transform into the two terms in addition form. Log x power n to the base a, we can write n into log x to the base a. The power we can write as a product with log. So just we will write it in the front of log. It means producting or multiplication. Log nth root x to the base a equals to the nth root we can write as a x power 1 by n. So power we always bring into front of the log. Like similarly n, here we have 1 by n. So 1 by n into log x to the base a. There is no difference to the above formula. If the power is in a fractional form, then also we will write the fraction in the front of logarithm or log. So these formulas we will use while doing the problems. Next, here one tabular form given for easy to understand. So you can see the headings: property, definition, example. Suppose a product is given, then how we will express? Log mn to the base b. Mn means m into n, that is a product of mn. So we will express as a log m plus log n. A base is the same for each log, that is b. To understand, if we take example log 9x to the base 3, here 9 into x is a product. So log 9 to the base 3 plus log x to the base 3. Next property, quotient. A quotient means the division form or fractional form, which is contains numerator and denominator. Then we say it is a fraction or quotient. Let us see. Log m by n to the base b. Log m to the base b minus log n to the base b. For example, log 4 by 5 to the base 1 by 4. Here base is also taken as a fraction. Then we write log 4 minus log 5 to the bases 1 by 4, which is in a fraction. As it is, we are kept for each log. Next, power. Log m power p to the base b. We will write p into log m to the base b. That is log 8 power x to the base 2 x into log 8 to the base 2. The power we are bringing into the front side of the log, or we say the product, the power is product to the log or multiply with the log. like a factor, or we say coefficient, also we can say like that. It is we can kept as a x into log 8 to the base 2. Next, equality. If log m to the base b equal to log n to the base b, then m equal to n. Here bases are equal, so we can write directly the logs are equal. That means m equals to n. Log 3x minus 4 to the base 8 equals to log 5x plus 2 to the base 8. So bases are equal, then we say the logs are equal. So again, no need to write log, just write its values. Its value means what is we are written log 3x minus 4, just write 3x minus 4 equals to 5x plus 2. Now we can see here logarithm operations worksheet. Calculate each problem. So some problems here are given and we have to simplify, or we have to calculate the values by using the formulas or properties. So log 8 to the base 2 plus log 4 to the base 2. First here I will explain one, remaining you can try. First question, we have two terms. In the first term we have 8 log 8. 8 can be expressed as a 2 power 3. So power is, we can write as a factor or quotient or product. So we will get the 3 into log 2 to the base 2. Log and its base are same, means the value is 1. So 3 into 1, 3. Similarly, the second term we can write 2 power 2 for 4. So we get 2. So 3 plus 2, 5. By using the formulas, we will find the values and simplifies. So here 10 questions given. So if you do these 10, you will know the formulas perfectly without confusion, and the formulas, if once you know, then it is easy in further exercise problems also. So to remember the formulas, not only we have to read, we have to apply, then it is remember to us. So to remember formulas, you must do and find these 10 questions. First one I explained. So remaining you do, and if you don't know how to do, or if you not simplifying, or if you are not getting, you and your friends both are equal answers or equal values, then I will tell you where you have done the mistake. If you don't know how to do, I will explain how to use the formula and how to apply the formula to simplify or to get the value of the question. First you try by observing formulas, and wherever you need you write the formula and kept it in the box, so that we can understand. By using this formula we are simplifying the step, or we are writing the next step or next line. Next, one question is given here, that is a log 2 to the base 3 plus log 3 of x plus 5 equals to log 3x minus 1 to the base 3. Here law 1, that is product rule, we are applying. So remember, the rule we are applying means, as per our convenient, if left is given we will take right, if right side parts are given we will apply the left side. So we have to remember the both LHS and RHS. In the formula, if left is asked, we have to write the its equal part of the right side. If right side given, we have to write the left side part which is equal to that. So here right side given, in the product rule, right side we have know the expression of two terms, and left side that expression is expressed in a single term. So from right to left now we are applying. So if we apply the product rule, we can write one base and the logs 2 are in the product form, that is log 2 into x plus 5 to the base 3. So here we added the two logs with same base in a one term with same base in a product form, equals to right side as it is we are writing or we are taken, that is log 3x minus 1 to the base 3. So bases are equal, then we can say it's the logs are equal. Next, 2 into x plus 5 equals to 3x minus 1. So if you multiply, then we get left side 2 into x 2x plus 2 into 5 10 equals to 3x minus 1. To know the x, we have to send the minus 1 to the left side and 2x to the right side. So 3x minus 2x is x and 10 plus 1 is 11. So this is the x value from the question. And here product rule we are applied, and another formula also we applied. You can see here in the green ink, log m to the base a equals to log n to the base a, that is m equals to n. Next, another question for solve. 3 into log x minus 1 to the base 2 plus log 4 to the base 2 equals to 5. In the question, in the first term we have 3 into, so the 3 we can write at inside the logs power. Here logs means the log which contain the value, or which is we are giving the log that. Here we have x minus 1, so the 3 is we can kept as a power to the x minus 1. So x minus 1 whole power 3 plus log 4 to the base 2 equals to 5. And bases are same, and if two logarithms with addition is there, then by product rule we can convert as a single term by producting their logs. That means we can write as a single term, that is log x minus 1 whole power 3 into 4 to the base 2 equals to 5. So to know the x, we don't want here the log. So from logarithms to we are expressing in exponent form, that is power form. That is, we say 2 power 5 equals to x minus 1 whole power 3 into 4. So 4 into x minus 1 whole power 3 equals to 32. So if 4 is went to the right side, it becomes 32 by 4. 32 by 4 we can write as 8. 4 8s are 32. So 8 can be expressed as a 2 power 3. So if powers are equal, then bases are equal. So x minus 1 equals to 2. Then x equals to, if we take minus 1 to the right side of 2, then x equals to 2 plus 1, that is x equals to 3. So here the last two steps not given, but I told you so that you can write that 2 steps, that is up to x equals to 3. Next, another question here given, that is log 500 to the base 5 minus 2 into log 2 to the base 5 plus log 32 to the base 4 plus log 8 to the base 4. So here we are simplifying by using rules. So first term as it is wrote, and second term we expressed as a log 2 power 2, remaining as it is. And next step, 2 power 2 means 4. You can see here the changed part is highlighted in the blue ink. In the first 2 steps they're changed, you can see by in blue ink. And next, log m minus log n rule applied for first 2 terms. So log m by n, 500 by 4. And last 2 terms we are applied as a product rule, log 32 into m to the base 4. 500 by 4 means 125. 125 expressed as a 5 power 3. 256 expressed as a 4 power 4. So 3 into log 5 to the base 5. 4 into log 4 to the base 4. So 3 into 1 plus 4 into 1, 3 plus 4 equal to 7. So next simplification, next question. log 18 into x plus 2 whole square by x minus 2 whole power 3 x plus 5 whole power 2. So the division is or fraction is expressed as two terms by using subtraction between them. So we can write log 18 into x plus 2 whole square to the base 3 minus log x minus 2 whole square x plus 5 whole square to the base 3. Log m into n, we can write log m plus log n. Similarly here also. So we have log 18 to the base 3 log x plus 2 whole square to the base 3, and if you multiply with minus in which are kept in a bracket, so with minus for each term we will multiply with minus. We will have minus log x minus 2 whole square to the base 3, and for second term also if you multiply minus into plus minus log x plus 5 whole square to the base 3. So 18 we can write 9 into 2, and second term we can write 2 into log x plus 2 to the base 3, and here that is not minus 3, it is a minus 2. Here the print is wrongly came, it is not 3. The third term you observe, it is a 2 into log x minus 2 to the base 3. Last term 2 into log x plus 5 to the base 3. Here 9 into 2 again we can write as a log 9 plus log 2. And the remaining terms are written as it is, and that equals to 9 can be written 3 square. So first term we can write 2. Like these remaining terms we kept. So the expression is expressed in so many terms. Next, see the box. Here one question is saying that simplify the log 24 plus 2 into log 3. So 2 into log 3 we can write log 3 square, power property, and by product property we can write as one term, that is log 24 into 9, that is 216, and it is expressed as a 6 power 3. So if you bring 3 front side, then we have log 6 to the base 6 value is 1. So 6 into 1, 6. Sorry, 6 log base 6 to the 6. Log 6 to the base 6 is 1. And 3 into 1 is 3, not 6. So this is the simplification. You can see here 216 is written as a 6 power 3, and the power 3 comes to the front side of the log as a product. So remaining part is value is 1, because base and log are equal. Log 6 to the base 6 is 1, so 1 into 3, 3. Next question, log x equal to 5 and log y equal to 12. Find the value of so and so. For that we are taking and we are simplifying by using the properties. We have 1 by 2 into log x cube into y to the base n. So x cube we can write 3 log x, and already log x we know 5, and log y we know 12. So substitute and simplify, we will get next log rules. Already we discussed log mn equals to log m plus log n log a to the base c, we can write log a to the base b and log c to the base b. See here bases are equal, so both are get cancelled, again it convert as a single term. So all these we are discussed, and log 1 by n we can write as a minus log n. So all these are we are discussed in the above presentations. All at a glance here given. The below blue ink you can observe log b to the base a and log a to the base b equal to 1, because b base and log, and in between that the product, so they may get cancel, and log a to the base a is 1. So and here the green side a power log m to the base a. So in power and log base, same, that log and power went off and just m we can write. So as per today's discussion, you try to do the exercise problems. If you have any doubts, we will discuss in next class. Thank you.